Hi everyone, this is Jaafar Hasan from PACademia, and today I'm going to talk about the flow volume curve. So let's begin with this graph. Let's start with the axes of it. The y-axis is the flow, and it's separated into positive and negative, positive being the expiration part and the negative being the inspiration part. The x-axis is the lung volume, and the more we approach the y-axis, the higher the lung volume is. So let's begin from this point, which is the residual volume. At the residual volume, we know it's as if we have just been done with a forced expiration. So now we're going to start with an inspiration. In this graph, we're going to have a forced inspiration followed by a forced expiration. So let's start with the forced inspiration. The flow of the inspiration increases it's being more negative. The more the negativity of it, the higher the flow of inspiration, and until we reach the PIF. Once we reach the PIF, خلاص, this is the peak, and the line becomes flat. This flattening of the line doesn't indicate that we're not increasing the lung volume anymore, but it means that the flow of inspiration is now constant. So as we can see here, the volume of the lung is still increasing, but the flow is constant. And after the PIF, we'll have a decreasing flow rate, but once again, the lung volume is still increasing. It was maybe 5, it became 6. However, at a lower rate of inspiration. Okay, now we're done with inspiration. We're left at the TLC. TLC is the total lung capacity. It would make sense that if we subtract residual volume from the TLC, we'll be left with the forced vital capacity. Now moving on to the expiration. Once again, it's into two parts. The first one until we reach the peak expiratory flow, and then the second part which has decreasing flow, but the lung volume is also decreasing, it's not increasing. What's important to know here is that the second part, like this part of the graph, is force independent. This is force dependent, and then this is force independent. So no matter what force you apply in the expiration, you'll end up having this slope at the end. And this circle is indicating the change of the flow volume curve, but in a normal tidal breathing rather than forced inspirations and expirations. Now moving on, we'll discuss what different pathologies have to do with this graph. Starting with this part, the obstructive diseases. As you remember, if you remember, in the last video we were describing the effects on this graph, the effects of emphysema and fibrosis. Basically, emphysema is obstructive and fibrosis is restrictive. So in emphysema, we said that we'll breathe at higher volumes. We need higher volumes in order to keep this equilibrium present, in order to have the equilibrium so that we won't have collapse or expansion. The same concept applies here. In obstructive emphysema, let's say, we'll have a much higher TLC, much higher residual volume, and you should remember that in obstructive diseases we have more difficulty in the expiration part. So yeah, I think these are the main points to cover here. You can read the table for more details about each component, whether it increases or decreases. Now moving on to restrictive. In restrictive, we said that they breathe at lower volumes, and an example of it is fibrosis. So what happens here is that both residual volume and TLC are much decreased. So here, and the inspiratory part is much affected. In obstructive, we have the expiratory part to be the most affected one, while here we have the inspiratory part to be mostly affected. So you have less residual volume, less TLC, and yeah, these are the main points. Other points are mentioned in this table, as I said before. And yeah, that's it for today. Thank you for your time. I hope that everything was clear. Thank you.